Monday, I'm not going to call it a test. I'm going to call it a quiz again because the two of them together will make up your test. Um, Thank you, Fred. But what it will be is it will be these 12 parent functions that you have to have memorized and the analysis on them. It will be completely non-calculator. It will just be you, a pencil, and the packet. So we're going to go over all of these. You'll have some work to do with them tonight and tomorrow night, and then your test will literally be a blank graph and then the analysis that follows for each of the 12. And so we're going to go over what each of those looks like. And some of them are super duper duper easy, and others of them are a little bit more complicated, but they're all parent graphs. So remind me, what does it mean to be a parent graph? It's kind of that one that we use all those transformations to decide what happens and what it looks like. There's no transformations done to it yet. It's just a starting point of a graph. So the first one that we are going to talk about is linear. You'll need to be precise in your graphing. I won't make you use a straight edge, but you'll still need to be. This means whatever x is, y is the exact same value. You will need to use exact points as you go through. Connect them accordingly. So there's what the graph looks like. We should all be familiar with the graph of y equals x. Yes? Of course. So let's go through some analysis about this graph. They'll get harder as we go, a little bit harder as we. What is the domain? Absolutely. What about the range? Same thing. If I need to slow down, tell me. This is just going to be this is going to be pretty monotonous today and tomorrow. I apologize. Dull. Boring. It's not really fun, but how about zeros? Does it have any zeros? One, and that's at x equals 0. Right. Any critical points? Critical points are maxes or mins. Or zeros, we got the 0. No. So there's no maxes and there's no mins here. Y'all okay there? Is it continuous? Yes, it is continuous. So there are no points of discontinuity. Does it show any type of symmetry? What type? Odd symmetry. It's an odd function. How about the end behavior? We didn't talk about this before. But as a recap from Algebra 2, as x approaches what? Infinity. As x approaches infinity, y, or f of x, approaches what? Infinity. That just means the right side of the graph goes up. How about the left side? Negative. That's exactly right. Questions or concerns so far? Looks like so that you know what it is you're looking at. So this is the test that you will take on Monday, and this is what each of them will look like. So you'll have the graph, and then you'll be asked to give everything that I just gave you. And you'll do this for all the parent functions. I just did. That is the actual test, and those are the actual answers. I am giving it to you. Yes, like literally, I'm showing you the test and what it looks like, and I am giving you the answers. There are 12 of them. No. This is why I split it up from 1-1 and 1-2, and then this section. So it's just this section. Obviously, they're important if I'm doing a whole test just on these because you have to know them so that at any point that I come up from after the test, you should be able to tell me. Yeah, Alex. Just the equation. You'll have a T-chart on there where you'll show me the important points that you use to graph. So for this one, I used 0, 0, I used 1, 1, and I used 2, 2, and that's all I used to graph it. There's a section, if you look, points used to graph, and you'll tell me the points that you use to graph. Because the point of it is that you're doing specific points. You're not just getting on there. If you just get on your test and you go, okay, linear, and that's what it looks like, I'm not giving you credit for that. This is easy enough as it is. You need to be precise. All right, questions? Ready to do the next one? Yes, Mr. Okay, guys. Let's do the quadratic. This one is y equals x squared. What does that look like? It's a parabola. Where is the vertex of that parabola? 1, 1, negative 1, 1. I would need at least this many points to graph it. So whenever I'm asked for the points used to graph, I need to make sure that I include 1, 1, 0, 0, and negative 1, 1, because I at least need that many points to graph to pick up the pattern of the parabola. What is the domain? Negative infinity to infinity. How about the range? Inclusive, yes, because the vertex sits at 0. What else about this one? Does it have any zeros? Zero. It has a 0 at 0, right? Is it continuous? Yes, it is continuous. Yeah, it didn't have zeros. Didn't have zeros. It doesn't show any symmetry. Yes, it's even symmetry. How can you tell? Right. Algebraically, the equation would look the same if you plugged in a negative x. Graphically, the y-axis cuts the graph in half. What were you fixing to ask? Yeah, that's what I was going to ask. How you tell. No, you don't have to. You just have to know which way they are. Oh, I lied. Yes, algebraically on the test.
So if the signs turn negative, it's off.
Yes.
But if the signs just stay the same, or like, you know what I mean? It's
Everything's set, yes.
And but if they like one sign changes and not the other, then it's
right. That's correct. How about critical points? Absolute min where? At x equals. By the way, we say it has a minimum value of 0. The value is my y value at x equals 0. The value of the function is the y value always. Some of you, that question came up when you were working through some of your review. When you ask about the value of the function, you're talking about the y. The value, if this is not going to be on the test Monday, but it does come up as we work through here, so I just wanted to just address this quickly. If you have something that has, let's say, this was a minimum, this would have a minimum value of 1 at x equals 3. The value of the function is always associated with the y. All right. In behavior, as x approaches infinity, what does y do? That's right. How about as x approaches negative infinity? Infinity. Questions, comments, concerns? Good. Number 3. How many did I tell you there were? 12. Number 3. The absolute value. What does this one look like? One, oops, 1, 1, negative 1, 1. And instead of rounding it these at a point, and this is actually, if you took the line y equals x, that very first one, right, and you took this piece and flipped it up and made it positive, you would have the absolute value, because that's what absolute value does, is it makes all negatives positive. Yes. How about domain? Are y'all okay with that? The range. Okay. Is it continuous? Yes, it is continuous. Extrema. Absolute min at 0, 0. Any zeros? At 0. How about symmetry? Even. In behavior. As x approaches infinity, what does y do? Goes to infinity. As x approaches negative infinity, infinity again, because both ends go up. Everybody good? No, you're not good. You don't understand. Oh. Well, why are you not good? Oh my goodness. Are you good on this? Uh, let's do, what number are we on? 4. Everybody, so far, everything we have done, we just did in Algebra 2. So nothing should be new for you. I did not. He does not. All right. What's this one look like? Absolutely. Good job. It is the inverse of a quadratic, and so that it remains a function, it's only half of it. It's the top half of a quadratic on its side. So 0, 0. 1, 1. If I had another, I'd probably go out to 4 and do like 4, 2. That's enough. Just enough to where you can pick up the pattern. No, I'm just showing you how it's a parabola on its side. You're welcome. 1, 1. What's the domain here? With a bracket. Yes? How about the range? Continuous? Yes. It has a, what'd you say? It has a 0, 0. What else does it have a 0? Absolute min. Yes, because can you draw it without lifting your pencil? Yes. Just because it's cut off there doesn't mean. Now, if it had another piece to it, then no, it wouldn't be continuous. Is there? How about in behavior? None. As x approaches infinity, what do I do for the other side? Because there's 2 ends, I need to address it. 0. Yes. Yes. Is everyone okay? I would ask you what your question is, and then I keep going. Starting to get a little bit harder. Well, not yet. Is this 5? I was going to try to push through all 12 today. And then we'll just practice with them today and tomorrow. I would like to get through all of them because then that way I'm not giving you the new stuff and you taking a test the very next day. And the harder ones are at the end. All right, cubic. 0, 0. 1, 1. Negative 1, negative 1. And we kind of look like this stretched out S. Okay, Brett, thank you. Call it whatever you want to call it. I tell you what. What's the domain?
Would that be 1, 1, and then negative 1?
Yes, negative 1. How about the range? Those are easy. It's got a 0 at 0. Symmetry. Look at you on it. Symmetry is odd. What else? What are we missing? No maxes and mins. Is it continuous? Continuous. In behavior. As x goes to infinity. Yep. How about as x goes to negative infinity? Yep. Everybody okay? What number? 6? I'm going to number them. I don't know. I just want to know. Okay, thank you. They are. They're stuck in 6th grade. Getting a little bit harder now. What does this look like? Yes, somebody said asymptote. This one does have asymptotes. This one has asymptotes at 0 here and 0 here. Yes, yeah, yeah. Well, they're going to be in the first quadrant and the third quadrant. Asymptotes. Those are asymptotes. So this one, 1, 1. And then what happens? What if I go to 2? 2, right. 2 would be, come on, right? Look at my equation. 2 would be 1/2. So what's going to happen is it's going to come and hug this asymptote, hug this asymptote. But that's not all of the graph. There's another piece of graph. What happens if I let, this is where your T-chart's going to come in really handy. What happens if I let x be negative 1? So I've got negative 1, negative 1, and then negative 2. These are going to be the same points. They're just going to be negative, right? So this is negative 2, negative 1/2. So it is going to do the same thing. Terrible. There we go. Yes. What is the domain of this function? Negative infinity to 0. How about the range? Same thing. How about zeros? None. Maxes or mins? None. Is it continuous? I hear yes and no. No, it is not continuous. If it is not continuous, why and what type of discontinuity? It's an infinite discontinuity because of the asymptotes. A jump is whenever it looks like there are two separate pieces like that. No, you didn't. Okay, I think it's on my desk or in that middle drawer.
You don't make mistakes.
I just don't. Hey, I have erasable pens. I have erasable pens. Yeah. All right. Yes. Yeah. On my desk. Yeah. All right. Is what? Does it have symmetry? Why? You can look at it as rotational, or you can plug in that negative x. If you plug in a negative for x, you end up with 1 over negative x, which changes the sign of everything, which makes it odd, because odd means opposite. Saying? Yes. Yes. All right. Here's where the rubber meets the road. Are y'all ready? We're getting into new stuff. Oh, I am sorry. No, it's still just 2. As x goes to infinity, y approaches 0. It's getting closer. Approaches means it doesn't necessarily have to be that value. It just means that it approaches it. Yes? I lied. We are going to go ahead and do 4 on this one. I'm sorry. Let me show you this. Let me show you this because this is introducing us to limits. What do you think this means? There's a little positive. So listen, what this means. This means as x approaches 0 from the right. Okay. So the other, if I write that, this is only when you have vertical asymptotes. Okay, listen. This is new stuff. There is new stuff in here. This is pre-cal. We are out of algebra 2 now, right? So I'm teaching you some new things as we go through some of these parent graphs. So listen. If I tell you that as x approaches 0 with a little plus sign, that means I'm asking you to look at the right side of 0. Come in from the positive side. Looking at this graph, as x goes to 0 from the right side. This is positive, right? Positive is always to the right. So at 0 on the right side, what is the graph doing? It's going to positive infinity.
So, look at right side graph.
Okay, so this is the right end of the graph. That's saying, but instead of thinking right, start thinking in terms, because our next section gets us into limits, and you're going to have to understand the positive infinity, the negative infinity, the 0 from the right, 0 from the left, and that kind of thing. So here, this is saying as x gets super, super big, that's this way. As I move that way, y is getting closer and closer to 0. Do you understand that? This one is saying as x gets closer and closer to 0 from the right. Because if you notice, they're doing two different things here, right? I can't just say as it goes to 0 because it's going up as it gets closer to 0 here, and it's going down as it gets closer to 0 there. Do you see the difference there? So as I get closer and closer to 0 from the right, what is the graph doing? It's going up. So that's positive infinity. So I can do the opposite of that now and say, well, what about as x approaches 0 from the left? Negative infinity because it's going there. I still have one more little end I have to address. As x approaches negative infinity, what does y do? It's still going to 0. As I go negative infinity, I'm still going. Yes. Say that again? No, no, not on the number itself above. There'll be another graph in a minute that we'll have to do it. Not the ones before this now.
So why do we have a negative 0 as an approaches 0 negative, and then negative infinity? Because I'm
This one is x approaching 0 from the left. This one is x approaching 0 from the right. This one is x approaching infinity. This one is x approaching negative infinity. There's 4 ends there, yes. Shh, guys, yeah, I'm listening. If they were going the same way, you could just do one. But if they're going opposite ways, you have to do the 2. Yes. Well, horizontal asymptotes are going to be as we go to positive and negative infinity. Vertical asymptotes are whenever we approach from different sides. So horizontal asymptotes won't impact from the left or from the right. You see what I'm saying? You're getting into a little bit of calculus now and horizontal definitions, and we'll touch on it a little bit later, but horizontal asymptotes are as x goes to positive or negative infinity. Vertical asymptotes are when I approach infinity when I come in, when the y part goes to infinity. Right now, just understand, for this one, you need the 4. And whenever I have a little plus, that means I'm coming in from the right, and this means I'm approaching from the left. Y'all okay? All right. I'm dreading this. I'm going to go ahead and tell you. Think about skipping it and coming back to it. Let me do that. Let me skip the 3 trig functions and come back to them. This is a growth. You have done this one for me before. This is, yeah. There is an asymptote at 0. If I plug 0 in for x, what is the y value? In other words, what is e to the 0? Are you all okay there? Yes. If I plug in 1, and this is the one you're going to have to kind of remember what value e has, you end up getting about 2.7. So, no. So you're just going to remember that that's about what it is. Because you remember what growth looks like, right? Growth comes up, hugs the asymptote one way, and shoots up really fast in the other. All right. What's the domain? How about the range? Is it continuous? It's a parenthesis because there's an asymptote there. In fact, there's an asymptote at y equals 0. Does it have symmetry? None. What's the end behavior look like? What about the other end? Yes. Let's do the next one. Oh, I am so hesitant to get to the other stuff. Log's good. I can do log because we did that, but the other stuff's. Natural log. Huh? Y equals natural log, ln. What is the natural log of x? Okay, that's when you don't have a base on a regular log. If I just had log x, that would tell me that there's a 10 here. What about if I have natural log of x? E. It's an e. This is the same thing as log. If it's e, Log base E.
I forgot everything about logs.
Okay. You didn't get to logs? Okay, let me just digress for just a minute. Logs are exponents, okay, and they're ways they are the inverse of the exponential growth, okay, of the exponential. So if you think about inverses, inverses switch x and y, okay. So it is a growth or decay that is laid on its side. It's twisted around. X and y have swapped places, okay. For right now, the most important thing that you need to remember is if I have b to the x equals some number, okay, I can write this as a log expression. I can say that this means that the log base b of a equals x every single time. I can go forwards or backwards with that, and you should be able to do the same as well. So just for example, because I know some of you don't remember, logs are always a struggle for students for whatever reason. If I asked you what is the log base 3 of 9, what would you tell me that equals? 2. Why? Because you're looking at this form and you're saying, what exponent, this is my b, I don't know my x, and it's got to equal 9. What would I need to raise 3 to in order to get 9? 3 to the second power equals 9. All right. Let's look at the graph. I'm going to have to adjust y'all somewhat. When I am in an exponential growth or decay, an exponential equation, where's my asymptote? I said it. Where's your asymptote? The x-axis at 0, right? If x and y switch places, guess where my asymptote is? Here. The y-axis. I have an asymptote at x equals 0. I'm going to need 2 points, at least. And I need to think about how logs work as far as exponents, okay? If you remember when we graphed these, I always told you the easiest thing to do was to make the base and this number match. So put in an E, right? And E is the same thing as about 2.7. Put in an E, and then also make this what? 1. Because if that's 1, that means the exponent was what? 0. Somebody said 0. 0. Anything to the 0 power is 1. Huh? What you mean? If the base was 1. Let me show you how this looks. All right, I've got natural log of E, right? Natural log of E, which means log base E of E. What does that equal? E to the what power is E? 1. X equals is a vertical line. Y equals is a horizontal line.
We're gonna practice. Do we just have to know those points?
Yes. It does. So I would go 1, 2, up to 1. right? And then if I plug 1 in that equation, so the natural log of 1, well, anytime this is 1, that equals 0. E to the what power gives you 1, it has to be 0. Yes. It is an exponential graph turned around on its side. Log base E. No, you have to change it this way. You take the base. Do you not remember doing this in algebra 2?
I'm so scared. Like, this was the thing I struggled with. I think I failed that.
So log, you take the base. This is the key to understanding logs. Being able to go from one form to the other. If you can do that, you can do logs.
The E is
Okay, but even if it's E, so if you can do that, the log base E, if I put an E in for X, what does that equal? E to what power gives you E? 1. What power do you put where it keeps it itself? This. It doesn't matter what that is. If these are the same, it equals 1 every single time. Absolutely. It doesn't matter. If they're the same, it equals 1. Thank you, Brett. Thank you. What is the domain here? Clearly, y'all already know what I'm fixing to give y'all work on tonight. I am giving you log work tonight. And because we have covered that in Algebra 2, it is a required mastery skill for this class. We did do it, Brett. Yes, we did. And it is a crucial topic for pre-cal. How about the range? Is it continuous? Yes. Does it have symmetry? No. What radius?
It's negative. It's negative infinity, positive. Wait, as to as y.
If it's x equals, it's up and down. If it's y equals, it's a horizontal line. Well, because if I try to put in, okay, we're going to go back to the log properties. If I try to put, okay. Is there any number, if I put 0 in, this is E, right? Is there anything you can raise E to get 0? Better yet, if I put any value in there, let's say 5. Is there any power I could raise 5 to and get 0? What's anything to the 0 power? 1. Now you're back to your exponent properties. No, you're not. No, you're not.
Yes. Okay, so there's nothing you can raise here.
Correct.
Okay. Just take all the
It will never. That's why. The good thing about parent graphs is most of the time they are. Yes. Yes. X equals 0. All right, everybody listen, because that's everybody. Y'all are getting caught up in the easy stuff. Okay, the equation of a vertical line is in the form x equals. So this is x equals 0. Even though that's the y-axis, it's x equals 0, right? Think about it like this is how I used to tell my Algebra 1 kids to remember. If you have x equals, it looks like an arrow pointing up and down, so it makes a vertical line. And then y has this little tail, make it look like a horizontal line. What?
So y
They wanted to know if this asymptote was x equals 0 or y equals 0. Let me tell you, name this point. 1. Name this point. What is true at every point on that line? X is always 0 because x equals 0, no matter what y is.